ได้ยินผมได้ยินผมไหมฮะโทษที
ได้ยินครับ
โอเคโทษทีผมติดเด็กดาราศาสตร์ด้วยโอเควันนี้เราจะเรียนเป็นภาษาอังกฤษเนาะอันนี้เมื่อวานเรามีการบ้านข้อไหนบ้างจำได้ไหม
มี1.9.10
ใครอยากจะทำอะไรบ้างเดี๋ยวผมทำให้ดูก่อนเนาะทุกคนยังอยู่ใช่ไหมอยู่ครบนะฮะเดี๋ยวขออนุญาตเปิดโน้ตเมื่อวานหน่อยผมโน้ตเอาไว้แป๊บนึงนะที่เดอ so the first problem will be 1.9 okay so what is the problem here what is the instruction for this problem hello 1.9 right so 1.9 is we want to find the transformation matrix R okay that describes a rotation by a 120-degree about an axis from the origin through the point 111 the rotation is clockwise as you look down the axis toward the origin in this case we have okay let me share the screen okay let me share the screen here can you see my screen now
not yet
you still can see mine one moment something wrong here okay I don't see either one moment. Okay, now you can see it, right? Is it clear?
yes
You can see it now, right? The problem here is I can't see my screen. Okay. Now let's consider this problem. So our rotation is not on the axis, okay? So the problem states that we have the axis of rotation from 0, 0, 0 to 1, 1, 1. Okay, so let me draw it for you here. So what we are doing here is problem number 1.9, okay? So we have the exit here. This recording. Okay, it's typical when we want to do something here. We draw a reference axis. So this point is 0, 0, 0. This thing is origin as the problem state. So the problem state that we want to rotate it by 120 about an axis from the origin through 1.1. So 1.1 is somewhere here. 1.1, 111. So this is the axis of origin. If you remember when I show you the rotation, we rotate about x-axis, okay? But now the rotation is not on the x-axis. Remember, if you look back to the problem, to the example that I try to show you here, see this one, this is the point, this in this y, c, and x is point out from the screen, and we rotate x-axis by theta here. So you get the translation, you get the rotation transformation. Now, instead of rotating x-axis, we rotate it this way. Okay. Any questions? Now, what we are going to do here is we're going to look from this direction. This is your eyes. Okay. If we look at this system here from this direction, what we are going to see is that we're going to see all three axes. Okay. Okay, we're going to see all the axes here. Okay, our axis of rotation is in this point. Let me use it the red color. Okay, at this point is a line from 0, 0, 0 from the origin to 1, 1, 1. Okay, you can put your pencil on it, on this point here, and your pencil is the axis of rotation. Okay, any question here? Do you understand what I mean, right? You put your pencil here, and your pencil is actually the axis of rotation. Okay. So now we are going to rotate it by 120 degrees here. Okay. Okay. Any questions? So let's put this one is X, this one is look through here, this one is Y, this one is Z. Okay. Okay. This is the original axis, just different perspective. No, and this one is what we normally draw, and now this picture here is what you see, this eye see. Okay. Any questions? No, everyone seems to be understand, right? seem to be understanding here. Okay, now we rotate it 120. Okay, so the x-axis will rotate 120, and the other one is rotate 120, and the other one is rotate 120. Any questions? Okay, now before we rotate it, let's take a look at this system carefully. Okay, let me delete this. Okay, and let's put this thing in O here. Is the origin. Now, if we put this thing back here, we project it on XY axis. What we have here is this one here. Okay. We project this left right here on the XY plane. Okay. When we project this, surely this one is not this one here. Oh, one moment. Okay, you want to know, right? Why is one here? Because it's 1, 1, 1. So it's projection on XY. This thing is 1. This thing is 1. So the angle here is what? What is this angle?
$45.
Yeah, 45. Okay, and this one is also 45. And if you project everything, it's going to be 45 in all direction. Any questions? So what about here in this picture? What is the angle between them here? What is this angle? What is this angle? What is this angle? Do you think they are equal?
Yes.
Yes. Yes, they are equal. And how much? How much? How much? What is the number here? This one is theta 1 here.
120.
Why is that? Why is it 120?
360 divided by 3.
Right. Good. Yeah. The whole thing is 360 degrees. I mean, the whole thing here is 360 degrees. So what you are seeing here is theta 1 here equal theta 2 equal theta 3, and they are equal to 120. Or you can say that it's 360 divided by 3 here. Now, the problem states that we want to rotate the whole system here. We want to rotate this by 120, and this one by 120, this one is by 120. So what does it mean? It means that if you rotate it, Z here, we will replace Y. Okay, after we rotate 120 degrees, okay, let me draw it underneath here. Okay, after we do 120 degree rotation, we are going to end up like this. That's the same geometry here, but the axis is different. Okay. Now, if this one was Z, after the rotation, C become Y here. So this C here will come up here, and Y here will come to here, and X here will come to here. All right, can you see that after the rotation? So y move this way here, x move this way, and z move this way. So x is replaced by y, z is replaced by x. Is that clear to you? So what does this mean? Okay, let's put things. So z come to this one here. Any questions? So to make them different, okay, when we rotate it, and this one is become x prime here, this thing become y prime, this one becomes z prime here. Because they are not x, they are not y, they are not z, they are the rotated x, y, z. Any questions? You seem really quiet here today. Chutima, are you there? Do you have any questions here? Why
Yeah, I'm here.
we end up like this? Is it clear?
Yes, of course.
Vichuta, are you there? Vichuta.
Yes. Yes,
Yes.
teacher.
Yes. Do you have any questions?
No, I'm clear.
Okay. Very good. Everyone seem very good at the English. Nalisala, do you have any point here that you don't understand? Okay. Is it okay now?
Okay.
So next, okay. So if we come back to what we did last time here when we rotate something, okay, we have to come up with this thing is the original vector, right? Here, this thing is the original vector. And what happened here? We want to find what? We want to find what is the AY and AC after the rotation, right? The objective of these questions here is that we want to find the, where is my matrix? Oh, here, we want to find this. This is what we want to find. That is the objective of this problem. So now we know how it is like, okay? We know how it looks like. We want to construct this matrix. How are we going to do that? Okay. Now we have to know that z become y and y become x, x becomes z. So we know that y now equal to z, right? Equal to z prime, and x equal to y prime here, and z equal to x prime. Am I right? So what does this mean? It means that our a here, our a x, hold on, sorry. Our a z here, that belong to this one, equal to what? Equal to ay, right? Because they're the same. And ax here, sorry, ay here equal to ax here, and ax prime equal to a z. Any questions here? Do you agree with this, with what I wrote here? Janta Nipa. Do you agree here? Do you think this is correct? Janta Nipa.
Teacher.
Yes. Do you think this one is correct or not? This one here.
I think correct.
Okay, you think it's correct. So, and anyone do not agree with me? Anything wrong here? No, everyone trust me, right? So you believe in me, even though I did it incorrectly, right? 621020033. Who is that? Can you use your name? The person whose student ID end up with 033. What is your name? Can you show your name also? Anyone knows this guy here? No, no one knows that. 621020033. Okay. Okay. No answer. Okay, let me write down there. 621020033. Okay. Now, so this one is correct. So we have that. So we have to write down what we did before. AX here, AY here, AZ here. Equal to what? All right, so AX here equal to AZ. It means that in case of AX, we don't have AX, we don't have AY, we have only AZ here, right? That means we have one here. Any questions? No? All right, so we do the next thing here. Next thing is AY is equal to AX. So AX should be 1 here. So AY equal to AX here when you multiply it here. All right, and then the rest is 0 here. And now we look at AZ here. AZ, which is this one here. Not this, not this one here. It's different AZ. But our AZ palm here equal to AY. So our Y is 1 here, and the rest is 0. When you do this, when you just doing a normal linear equation, we get AX is equal to AX multiplied by 0 plus AY multiplied by 0 plus AZ multiplied by 1. AY here equal to AX plus 1 multiplied by 1 plus AY times 0 plus AZ times 0. AZ here, AX times 0 plus AY times 1 here plus AZ times 0. So by doing this, what do we get here? This one is 0, 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 this one is 0. So AX will be equal to AZ, which is AX prime equal to AZ. That is correct, right? This is what we get. ay here equal to ax, ay prime equal to ax. That is correct. Now az here equal to ay, az equal to ay. So that's it for this problem. Any questions? No? Any questions? No? Everyone understand, right? Now, what is the next problem? I will do until 11:15 and then the rest will be yours. So it is 1.1, yeah. Okay. Okay, next I will do 1.13 for you. Let me check 1.13. Okay, it's rather long, so anyone want to do this problem for me, 1.13, or you want me to do it? No? Very quiet. Okay. All right, then. Now, the problem 1 point. Okay. So we know that our R is the separation vector. All right. Okay. And to get the separation vector, we need to know R here and R prime. Okay. The problem state that our R is X, Y, Z, or you can write it down in terms of unit vector. It's like that. Okay. You can write the vector this way or this way. And this one is X prime, Y prime, and Z prime here. X prime I here, plus Y prime J here, plus Z prime K. Any questions? This just we get from the problem, from the statement, from the problem statement. And then the first question is that what is the value of gradient of square here? Okay, it need to be square because this separation vector is itself is vector. You don't have gradient of a vector. Okay, so this has to be some value, and it's the problem want us to prove that gradient of r square here is equal to 2r. Okay, 2 times separation vectors. So before we do that, we need to know that our here is equal to x minus x prime here, I, right, plus y minus y prime here, j here, plus z minus z prime k. Is that okay? Anyone understand, right? And its magnitude, magnitude is equal to x minus x prime here square plus y minus y prime square plus z minus z square here, and the whole thing is to 1/2 here. Any questions, or you can write it as a just without the arrow on top. So now we find the gradient of this term here, this r square here. So you just put it. Okay. And we need to put the vector, the unit vector in front. And inside here is what? Is the x minus x prime square. It's not difficult. It's just tedious, okay? It's just long. And this for the I here, and you need to find for what? For j here, y direction. But don't forget this. It has to be y here. But when you integrate, you have to integrate everything here. Y minus y prime here, plus c minus d prime here, and plus k. Questions?นัททีโอเคไหมมีคำถามไหมครับ มันแค่ยาวเนาะอันนี้
ยังไม่มีค่ะอาจารย์ตอนนี้
มีใครรู้มั้งรหัส6210203นี่ใครอ่ะ
คิด
203
เป็นแท็บซี่ครับ
ใครนะ
แป๊บซี่เมื่อกี้แป๊บซี่บอกว่ามันไม่ได้ยินเสียงค่ะ
แล้วผมไม่เห็นชื่อไงเมื่อกี้ผมถามแล้วเห็นเงียบไปโอเคงั้นต่อเนาะโอเค let's we continue let me continue here and what is the first term here can you tell me so in the first term here we get let me show okay let me write it down for you so this has to be I also, right? And because we take the derivative with respect to x, whatever has y in it and has z in it becomes 0. So we only have this. Okay, plus j here. Okay. So now it's really simple. What do we have here? So we take the derivative with respect to x here. So it become I here. And we take the derivative with respect to x here. It's become 2x minus x palm here, right? And you multiply it with what? 2 here. And we get 1 here. This is what we have. Okay. And the other one is plus j here. And what do we have? We have the same thing. We have 2x y here minus y palm here. And we have also k here and 2z minus z palm here. And we pull 2 out of the equation. We get I here, x minus x palm plus j, y minus y palm here, plus k, z minus z palm here. Okay, what is this? Is it? Yeah. See, they're just the same thing here. This one here, this one here, this one here, this one here, and this one and this one. So we actually can say that the gradient of r square here is equal to 2 times the separation vector. Is that clear? Any questions? Any questions? No. So now we try B here. So what do we want to derive here is this one here. Gradient of 1 over r equal to minus r, the unit vector of r divided by r square. Okay, this is what we want to derive. Any questions? Do you think it's difficult, this one? Okay, the same thing. I'm going to do the same thing here. So we write down I here and d by dx here, right? And we have 1 over r. So what is over r? Over r is this one here. This is over r here. So it's 1 over r. So 1 over r here equal to what? Equal to x minus x palm square, right? Plus y minus y palm square plus z minus z palm square. The whole thing was minus 1 over 2. Okay, it was 1 over 2 before here. Since it's 1 over r here, so it's become minus 1 over 2. And now we're going to do the derivative of this. So we just let me put just the bracket here, and just make this thing equal to the bracket here. Then the whole thing is too long. I don't want to write down. Okay. Do you think it's possible to get rid of this and this for x? Do you think it's possible? So let's check it out here. D by dx here, and what do we have here? X minus x palm, right? Square plus y minus y palm square plus z minus z palm square, and the whole thing is 1/2 minus 1/2. You cannot say that this term becomes 0, this term becomes 0. You cannot do that because the whole thing has the power of minus 1/2 here. So they are the same term here inside the square root. When you take the derivative, you cannot just simply remove it. Okay, we have to take the derivative of the whole system. Okay, so let's check it out. But it's going to be easy because if we do this thing will just have the same result. This thing also have the same result, just different term. Okay, in this case we have minus 1/2 we pull in front. Okay, and the whole square root here become minus 1/2 minus 1. Okay, the whole square root here is this thing here, the whole parenthesis, plus no, it's not plus. So we have to take, now we take the derivative of the outside of this term here. It's done. Now we have to take derivative inside we have to take derivative of this. Okay, and the rest is 0 and plus 0 plus 0. Okay, so it's become minus 1/2 and the whole divided by 2, 3 divided by 2, and take this derivative, it's become 2x minus x palm here. All right, this thing is equal to this. We are done here, and 2 cancel 2. What do we have here is minus, and the whole system here to the 3/2 and x minus x palm here. Is that okay? The same thing also can also be done for y and z, okay? If we consider dy here and the whole bracket here, we have minus also 3/2 and become y minus y palm here. Any question? Also in C direction, we have the same thing here, but just different, just different last term. All right. Now what are we going to do? We just put it back, put this thing back into x here, and this thing back into y, and this thing back into C here. Okay. And we have this. We have that. Okay. Have this equal to minus. I'm not going to write down the whole thing. Okay. See, every term here has the front term here, and here. So I pull it out of the bracket. Okay. So what we have left inside is that x minus x palm here, I plus y minus y palm j plus z minus z palm k. Any questions? No questions. All right. And now let's take a look at this term here. This term is, we can write it down like the in full, okay?
full version is we have like minus x minus x palm square plus y minus y palm square plus z minus c palm square. The whole thing is what? The whole thing is minus t over 2. All right. And we know that this term here okay, we know that this term is basically this term. Okay, we put it back down here. Okay, is it still the negative sign here? No, there's no negative sign anymore because it's become this term already, so it's 3 over 2. Agree? Any objection here? No, no objection, right? No, okay. Now. If I pull this thing inside, I do it very detailed, okay? I don't want you to confuse. Okay, and the whole thing is 1 over 2, okay? And this thing is to the 3, okay, to the third. Any questions here? So I pull this 2 inside and it's become the power of 3. No questions. Any questions? I try to do it step by step. I don't skip any step, okay? And what about this term here? What is equal to what? It's equal to this term. So we have minus 1 r to the 3, yeah. Okay, so the whole bracket here, the whole parenthesis here is equal to this one. Now we replace it into the equation here. We have gradient of 1 over r equal to minus 1 over r to the third. And the whole thing here is what? Is oh, no, not this one. The whole thing here is what? Is r here. Right? The whole thing is r here. So we have this. Any questions? And we know that minus 1 over r square here. And this one is equal to what? The unit vector of r here. So we have gradient of 1 over r here equal to minus 1 over r square. This term. Is it what we want? Yes, it is what we want. So we can say that. Any questions? No? No questions. Okay. Now, we going to try to generalize what we just did for A and B. Okay. So the last problem is, what is the general formula for gradient of R with the power of n? Okay. So we try to generalize the whole thing. Okay. So we're going to do it for just x. Okay. So this is what we are going to do. So see, we want to find the gradient of R to the n. What is the general formula? General formula for this, okay? If we want to write it down, it's become like this: d by dx here, R to the n plus j, d by dy, R to the n plus k, d by dz, to the n here, right? Now we are going to perform our calculation on only first term, and the second and the third term, they're just going to be similar to this term here, just different derivative, just different parameter inside. It can be either x and y or z. Okay. Now just try this term here, d by dx here, to the n. Okay. Just look at the big picture here. We have n, right, to the n minus 1 here, and d by dx here. Any questions? No questions. Everyone understand it, right? And what is this thing here? dr by dx. dr by dx. Have we done that? dr by dx. What is our r? Our r is 1/2, right? Let's see. Okay, this is our r here. So we take the derivative with respect to x. What we have this. Okay, first we take derivative, we get 1/2 here, and we get the whole thing, right? The whole thing is r, right? R become 1/2 minus 1. Okay. And everyone understand, right? So we have 1/r. Okay. Any questions? dr by dx is 1/2 minus 1 minus 1/2. Okay. And we dip inside, we take the derivative inside also, right? So inside, what do we have? We have 2, right? 2 x minus x prime here, and we have the whole thing. All right, so we have 2. This one has to be it's not I here. We put 2 out from the equation. We would have only take derivative with respect to this thing is equal to the by dx, and this term is 0. This term is 0. So sorry, I forgot that. Any questions here? Any questions before we go further? Anything I did wrong here? No comment. Someone noticed something that I did incorrect here. Something in this equation is not correct. Can anyone tell me what it is? No one can tell me. All right, let me delete this. Let me erase all this here. Okay, and we're going to do the derivative like, straightforwardly. Okay, 1/2 we pull out. So what we have inside is this one here. Okay, so we take derivative, just 1/2 here, and it's become 1/2 minus 1. Okay, and we dip inside, we take the derivative inside, we get 2x here. Not 2x here, 2x minus x prime here. All right, and this term here become 1/2 here, and what inside here is minus 1/2 and 2x minus x here, and it's become 1/2, 1 over this term here. Okay, and this term is what? This term is equal to r here. Therefore, d by dr here, dr by dx here, equal to 1/2 r and 2 x minus x prime here. Okay. Any questions? So this one is not right. So it should be equal to 1/2 r here and 2 x minus x prime here. Any question? No question. No question. Okay. So if no question, so we cancel 2 out, we have this. Okay, this thing is only for what? For x here. So if we write it down, the whole thing here, equal to what? I here, right? And we have the whole system here in n minus 1 divided by r here, and x minus x prime here. And the other thing is that j here, j is the same thing here, is n to the n minus 1 here divided by r, and y minus y prime here plus k n, right, to the n minus 1 divided by r here, and z minus c prime. Any question? Do you agree? Do you agree with me here? Wapa, do you agree? Do you agree with me, Wapa?
Yes, teacher.
Okay. What is our next step? What is our next step? Our next step is we have the same thing here. You see that, right? We can pull it out of the equation. Just this. Okay. And I have 1 over r here. Just this one here. And we have what inside here is this one. And this thing is what? This thing is basically the vector, the separation vector itself. Okay. Now what we have here is that this one here is equal to what? N to the n minus 1 here. And this thing here is equal to r here. So we can. And what is this? This one is equal to this. Therefore, this thing here equal to n to the n minus 1 with the unit vector r here. This is the general form of this thing. Okay, so I finished my part. Now it's your turn. Pepsi, are you still here? Pepsi, are you here?
อาจารย์คะ
Yes.
เป๊ปซี่บอกว่าเป๊ปซี่เข้ามาในซูมแล้วเป๊ปซี่เห็นแต่อาจารย์เขียนแต่เป๊ปซี่ไม่ได้ยินเสียงอาจารย์ค่ะ
อ้าวแล้วคุณได้ยินผมปะพวกคุณได้ยินผมปะ
หนูได้ยินค่ะแต่เป๊ปซี่มันไม่ได้ยิน
น่าจะเป็นเครื่องแป๊บซี่แล้วแหละทั้งนั้นอ่ะปล่อยเพื่อนคุณพูดได้ไหมปล่อยให้แป๊บซี่ลองพูดดูได้ไหมว่าได้ยินปะแป๊บซี่ can you speak where's Pepsi here she's not in the group okay ชนทิชาI don't see the sign the microphone sign on her name okay Pepsi can you hear me now Pepsi can you hear me
หนู
now
ไม่ได้ยินอาจารย์ค่ะ แต่ว่าหนูเห็นที่อาจารย์เขียน
คุณได้ยินตอนนี้ได้ยินไหม
ตอนนี้หนูฟังอยู่กับกิฟอะค่ะ
เอาเหรอเครื่องคุณมีปัญหาหรือเปล่าพวกคุณทำสักข้อหนึ่งให้ผม you should try one problem here you can choose which problem you want to do it what we did 1.13 here and what is it? 1 point what? And 1.9. So we did only 1.9 and 1.13. This is what we did. So what we have left, we have 116. Anyone want to do 116 for us? Nattini Dinmyeong, could you try 1.16 for us? Come on, don't waste time here. We don't have much time left. We have only 30 minutes. Okay. So, Nattini Dinmyeong, do you hear me? Do you hear
Yes,
me?
teacher.
Yes. Can you share your screen and be live? Solve the problem 116 for us. See, this is what we want to do here now. 116. Okay, let me stop sharing mine and you can share yours. Okay. Can you share your screen now? Okay, I allow everyone to share the screen. You should be able to share your screen now. Please share your screen. Nattini, can you hear me now? Can you hear me now?
อาจารย์หนูต้องทำให้อาจารย์ดูใช่ไหมเพราะหนูยังไม่ได้ทำข้อ16
คุณทำข้อไหนมาบ้าง
ที่หนูทำ หนูทำข้อเมื่อคืนหนูทำข้อ9ที่ยังไม่เสร็จแล้วก็ข้อ11กับ20ค่ะ
11 กับ 20 นี่คือเสร็จแล้วใช่ปะ
11เสร็จแล้ว20น่าจะผิด
รู้ได้ไงว่าผิด
ไม่รู้
อาจจะ
ห
ไม่
นู
ผิด
เดา
ก็ได้ปะ
ไม่แน่ใจอ่ะอาจารย์แต่น่าจะผิดแหละข้อ20
ทำไมถึงคิดอย่างนั้นทำข้อ 11 ก็ได้โอเค show number 11 alright so I'm waiting for you to share and be live with for us. You can share your screen, right? I allow you to share your screen.
อันนี้ข้อ11ที่ทำเมื่อคืนค่ะ อาจารย์เห็นสกรีนไหมคะ
ทำเป็นขั้นตอนให้เพื่อนๆดูด้วยทำเป็นขั้นตอนทำแบบที่ผมทำเมื่อกี้ให้เพื่อนๆดูแล้วก็ in English please ได้ยินผมไหม
ได้ยินค่ะแต่หนูคิดอยู่ว่าหนูจะพูดยังไง อาจารย์พูดไทยไม่ได้เหรอ
ไม่ได้เราต้องพูดภาษาอังกฤษบ้างนะซ้อมหัดพยายาม
เออ
try so you can try to share your screen right and then try to derive your first problem like problem A anyone want to help so this problem is very simple and we don't want to spend time on it spend a lot of time on it we don't want to do that Natini you don't know how to begin
yes.
try you need to try to speak English from time to time you will need it
อืม
try anyone want to help her
help me please
Chutima do you want to help
Okay, I
Chutima
will try.
please
Okay, I will try.
Uh,
For the gradient, for
okay you can begin
okay, for the problem 1.11, for A, we got the function that is f x, y, and z that is equal to x squared plus y power 3 and z power 4. And when we try to use derivative for this function, we can get 2 times x x hat minus 3 times y square y hat and
4 times z power 3 z hat. Can you get it?เออทุกคนเข้าใจกันไหมคะ Okay, for the part B, that it function f that is equal to x square times y power 3 and z power 4. We try to use derivative for this function, and we can get
I think we can say that the operator operates on the scalar function is the gradient, and then for the formula of the gradient is look like that in the screen, and the other thing that we need to do is the simple derivative. So you can continue. Yeah, go.
okay. For the part 3, that is function of จริงๆพูดใหม่ได้ไหม
First, I try to explain the operator operate on the scalar function is called the gradient, and as we can see in the screen, the gradient operator of f is equal to the x hat the fx by dx plus y hat the f by dy and plus c hat the f by dz. So we substitute the f into the f in each of the component. So we need to do the derivative. So as we can see in the screen, the derivative is also done. Yeah, I cannot point on the screen, so it's not, I can speak only like that, like this. Just in mind, I think Kukai, you can explain the derivative after this.
For the part A, for the derivative that we get, you can see that for the derivative of function x square plus y power 3 and z power 4, we can use the simple derivative. So we got 2 times x and x hat plus 3 times y square y hat and 4 times z power 3 and z hat. Did you get it?
Yes.
Okay. For the part B, we try to try to use a derivative of this function, and for the derivative of this function, we can get 2 times x times y power 3 times z power 4, and then plus y hat that is times y 3 times x square y square and z power 4 and plus z hat times 4 times x square times y power 3 and times z power 3. In the part, did you get it?
Yes.
And next, for the part C, we try to operate this function. And for this function, we can get x hat times exponential x times sin y and log z plus y hat times exponential x times cos y log z and next plus z hat that time exponential x sin y over z. In this part, did you get it?
Yes.
Okay.
Anyone have questions? So who is going to do the next problem?
Teacher, do we move to the next question?
Yes. Any questions you can choose and anyone can do it, but it's your job to do it, okay? And show it to me, or you can do it also, Jing. You can choose any questions that left, okay?
Okay.
Jing, do you choose the question? You can do it.
Do you see my screen?
Yes.
I will do the question 1.16. For this question, we need to sketch the vector function of this vector and compute the divergence. So first, I would like to sketch the vector function, which I use the Mathematica program to sketch. So, as you can see, the vector is in the form of 1 over the length, the magnitude of the vector power 3 times the vector r. So, first I need to tell you that the vector r is r equal to x I hat plus y j hat and plus z k hat. So, from this and this, we can write the v equal to this function. So we use this function to plot in the Mathematica. Which is this. Which is this. And so this is the vector v that we sketch on the Mathematica program. As you can see that the vector v at the origin is at the high magnitude, and at the when it's far from the origin, the magnitude is decreased. You can see from the picture, from the color or the region. And next, the one us to compute is divergence. So, as you know that the divergence is the product of the divergence need to be scalar. So, and this is the how the divergence operates on vector v, and it is also be the scalar product. So we do the divergence like we need to do the derivative of this function, which is come from the divergence operate on the v. So from this derivative, we will get this. with it is like the chain rule and the how to do the derivative of the power. So from this we get we need to do the derivative of the multi. I don't know how to say that. I think it is dip ผลคูณ yes it is something like that because we have the x and the x in this term, so we need to do the dip in a different way. So first is the x times the d of this by the x, so we will get this, and this times the derivative of x, which is 1. So we do the same thing for the y and z component. So in the final, we can see that we can put the same thing on the x, y, and z component, which is this part, they have the same. So we pull it out, and in this part, it also same. We can sum them. It is this, and the leftover is the x square and y square and z square. We did this. So we can time this together, that we will get the index of -3/2. So this thing is the same, but in a different direction. This is negative and positive. So we will know that final we will get the divergence of v is 0. So I don't know, I'm not sure that is correct, but in my opinion, I think the divergence of v is equal to 0, mean they have the, as we can see from the picture, the vector v has it look like the vector that come out of the origin that have the same magnitude but different direction. So if we sum the vector together, this thing will cancel and this thing will cancel, and it is symmetry, so the divergence of v is equal to 0.
Okay.
Okay, I'm not sure that we can explain in that way. The divergence is equal to 0.
Actually,
finish.
can you still hear me now? Actually, the divergence of v is
Yes.
0 everywhere except at the origin. The reason is that our v is 1 over what is it? Our v is divided. Our v has the term, the denominator term, the term underneath the line, r to the third, right? Right? R to the second,
Yes.
not third. Okay. So this term is the problem.
Yes.
This term is, if r is equal to 0, we will actually blows up. Blows up means it go to infinity.
Okay.
So this is the problem. Okay. In fact, divergence of v is actually infinite at that point. At the point r equal to 0, and actually 0 everywhere else except at that origin. Okay, at r equal to 0. Okay. Any questions for Jing from everyone?
Is
No?
okay.
I still don't understand why the figure look like there is a lot of vector coming out from the point, but why
That is
zero?
vector v, right? I think the one that you just show is vector v, right? Not the divergent of v. This is the divergent of v. The just the v itself. That's just v, right? I think he just plot v alone, not the divergent of v.
Yeah. Do you see my screen?
Yeah, not so clear. It's
The
so
divergent.
small. Where's the divergence of v here?
I think
Is that the divergence of v? Okay. It's equal to 0.
I think
If you look at the
internet is slow.
okay, if you look at
Yes.
the vector field that you have, can you come down a little bit? This is your divergent. Are you sure?
Vector.
This is
No, the vector.
divergent?
They
Oh, the vector, right? Okay.
they told to plot the vector.
Right. Okay, I thought that is the
But the
divergent.
divergence
I
is
think
equal to 0
0.
everywhere. Yeah.
Right, everywhere except at the
But
at the origin. Okay. The problem is because r is going to 0 and v go to infinity. That is the problem. Okay. It sure 0 everywhere else except at the origin. At the origin, it's not 0. It's a little bit weird, but yeah, it's not 0. Well, we will see about it later. We will see why it is not 0 at the origin. Okay. Any questions? No? Hello? Yes. Okay, I think if no questions, I think we call it a day today, okay? And next time, try to prepare your problem in English, okay? Okay, everyone, we have a deal at the beginning that our problem session will be in English. And you guys need to prepare your work in English. So you can speak in English, okay? Everyone is clear? Understand the rule here? Everyone understand the rule, right? Okay. Okay, everyone is really quiet. Pontipa, do you understand what I said? What I just said? Pontipa.
Yes, I understand.
Okay. So next time will be yours. Okay, your time to do the problem. Okay. So prepare yourself. All right. Okay, I think everyone is hungry now. It's lunchtime. All right then. Call it a class now. Have a good time. I'll see you again next week, right?